Remember the conic sections. The conic sections are the circles, the parabolas, the ellipse, and the hyperbola. Now each one of these conic sections come from this equation, ax squared plus cy squared plus dx plus ey plus f equals 0. So this is all of the conic sections that are just centered at 0 and not moved through an angle of rotation. If they are moved through an angle of rotation, we can add a term, the bxy term, inside of there. But if they're not rotated, we can use this basic equation. And if you would like, these are the cheats to determine which type of conic section you are working with. Now, the other way that you can determine which type of conic section that you're working with is to actually complete the square, and the bonus to that is that we can learn a lot about sketching them very quickly. So for example, in the hyperbola, after completing the square, you'll have a minus inside and it will be equal to 1. And it will either open up or down depending on which is the transverse axis. Or it will open left or right. For the ellipse, it's the same. The equation is very much the same, except as the hyperbola, except there's a plus inside. It's also equal to 1. And now, if it's, it can open up if the major vertical or the major axis is vertical, that is the y-axis, or it will open left and right, or not open, but be long ways left or right based upon if the horizontal axis is the major axis. Now, the other one is the parabola, and when I look at the completing of the squares, we know we have a parabola when one of the variables is squared and the other is not. So, for example, if it opens up or down, then the x will be squared, but the y will be not be squared, and if it opens right or left, then the y is squared and the x is not. So from there, we can identify various types of conic sections just from their equation. So for example, if we had the equation y squared minus 2x is equal to 6, we know that one of the variables is squared, the other is not. This is going to be a parabola. And specifically the y is squared and not the x, so we know that this parabola is either going to open left or right. So from there we can look, and we need to form the equation y minus k squared is equal to 4p times x minus h. And again, h and k will be the coordinates of not the center now, but this will be the vertex of the parabola. So let's modify the equation that we are given. We need all the y's on one side, so we get y squared is equal to 2x plus 6. We don't really need to complete the square. We know that y squared is the same thing as y minus 0 squared. We can factor out the 2, and we'll be left with x plus 3 and the other factor. So from here, we can read that the vertex, h comma k, of this parabola is at negative 3 comma 0. From here, we can look and form the 4p factor. So we knew that 2 must be equal to 4p's, so 1/2 is equal to p. P is greater than 0, so we know that this parabola will be opening right. And from there, we can do a quick sketch of the parabola that we're working with. So for example, here's our vertex at negative 3, 0, and we know that it opens right. Now there's a lot more information that we could use, but as a quick sketch, this will work for us. One of the things we could determine, obviously, are what are these points, what happens when x is equal to 0. And so for that, you just go back in and we see that we know that our equation is y squared is equal to 2x plus 6. If x is equal to 0, we just get that y squared is equal to 6. So the y coordinates there are going to be plus or minus root 6. So here's the positive, and here is the negative.